Hello everyone, this is AceInvade's presentation for the development of neural network in order to forecast the cargo energy demand. So if we access the energy demand database, the first column is a specific time and the second column is an energy demand corresponding to each time series. So in the first step, we need to process the data set, which means we need to normalize the data. Instead of using Excel to calculate the mean and the standard deviation, we use a method in Lab 1 to calculate the stats in Lab 2. So use this method, we can have the mean and the standard deviation directly. We need to notice that if we want to process the second column of the dataset, we need to run the stats of column B. After that, in the normalization step, we use the formula of normalization in Lab 1. We can get the normalized data which is stored in data file. If we open the data file, we can see the normalized data. Afterwards, we can separate the data in data file for training and testing after we run the pref.m. In this step, we are going to calculate the persistence of the dataset. So our goal is to beat the persistence loss, which is 0.116. In the second step, we need to set up the config of the training set. We set the repeats to 4, n sets to 16, and the 64. Set the input sets to 20. We use 10,000 maximum iterations, 2 solver tapes, dropout probability, and weight decay. Then we do the training step. In the test loss form, we can see Adam solver will get smaller test loss compared to the SGD solver. So in the training step afterwards, we are going to use SGD solver in order to save training time. In the next step, in order to optimize the training process, we need to add input features and increase the dropouts. In other words, we want to decrease the test loss. We need to add more features and other dropout probabilities. So this is our loss graph corresponding to the config mentioned before. We can see that the lowest test loss is 0.0127, which already beats the persistence. However, in the loss graph, the test loss is too low, so the red line are in the bottom of the loss graph. The neural network tends to memorize. Thus, the neural network needs to be improved. The next slide is the log correlation graph, which looks good, as you can see. So in order to optimize the model, we can check other configs. In this set, we use 2 layers neural networks. In the training set, we use more NN set and more repeats. We use the same input set and the maximum iterations. After training, we can get a loss graph. We can see the model still tends to memorize, but it doesn't matter. We just need to find which N set is better. We can see that the lowest loss is 0.0225, which corresponding to 64 N size. Also, we need to try the N set from 64, 128, and 256. And we found that the lowest loss is still corresponding to 64 N size. So in the following training set, we are going to use N set of 64 to optimize the training model and reduce the training time. The first graph shows the actual versus test prediction. Discrete plottings in the graphs can be considered as straight lines, which represent that the prediction we made looks good. The second graph shows the test prediction. As we can directly see from the graph, the actual line and the prediction line are mostly overlapping, which are also represent that the prediction is good. This graph shows the log correlation. This is just one peak at log 0 and no second peak on the graph, and this is just what we want for a good prediction. As mentioned before, in order to minimize the test loss, we finally set the N set to 64 to do the final prediction. After training, we can get a loss graph. We can see that the line of the train loss and test loss are very close. The discrete plotting in the first graph looks more like a straight line, and the images of the actual line and the prediction lines are mostly overlapping, which means that the prediction looks very good. And this is a log correlation graph for the prediction. Just one peak at log 0 and no second peak on the graph.